Hey guys, welcome back. All right, guys. So continuing on with our sequences and series unit, this video topic is called geometric series. Okay. So again, guys, series. What this means is the sum of a sequence. Okay, and this is really because this is like the mathematical meaning of this word over here. Okay, so geometric series is going to be the sum of a sequence. Okay. So this first one, guys, is very simple. This is an example of a geometric series over here. My common ratio is -3. -2 times -3 is 6, times -3 is -18, times -3, and so forth like this. So this sum would be -2 plus 6 minus 18 plus 54 minus 162 is 122. So a geometric sequence, guys, is a list of terms where any two consecutive terms have a common ratio. Okay, for a geometric series, it's going to be the sum of a geometric sequence. All right. All right, derive the geometric series formula. So guys, if you remember the way that we defined a geometric sequence, our first term was T1, our second term was T1R, our third term was T1R squared, T1R to the fourth, and our last term was T1R to the n minus 1. Okay, here's what we're going to do. So then that means then Sn equals, so this only difference, guys, between the sequence and the series is I'm replacing the commas. So a sequence is a list. That means the series is the sum of these guys. All right, guys, here's going to be kind of a weird thing we're going to do. Okay, it's weird, but like, we guys going to say it's weird. The first time I saw this one, I wouldn't have thought of why to do this step over here, but this step actually does lead to the answer. So here's what we're going to do. We're going to go RSN, so this means R times this guy over here, minus SN. Now if we do that, we get RSN minus SN like this. So if I have RSN, that means I'm going to multiply each one of these terms times R. Sorry guys, I'm just going to rewrite this. It's a little bit better over here. So this is going to be like T1 times R. This guy times R squared times R is T1R squared. So this one and then this one over here times R will be T1R to the n. Now we're going to be subtracting Sn, which is this guy listed over here again. So it's going to be T1 plus T1R plus T1R squared plus T1R cubed plus T1R to the fourth plus T1R to the n minus 1. So the idea, guys, if I'm subtracting these two equations here, we'll have T1R minus T1R. So those guys disappear. T1R squared minus T1R squared, those guys disappear. These two disappear. These two disappear. These two disappear as well. The only ones that I have left is this term and this term. So I have T1R to the n minus T1. So So guys, I'm just going to rewrite this again. We have RSN minus SN equals T1 R to the N minus T1. So the idea that we're going to do here is we have a common factor of Sn on the left-hand side. So we're going to factor this out. And then if I divide both sides by R minus 1, and this is going to be our geometric series formula. Okay. Yeah, here's our geometric series formula, guys. Another version of this one as well. Like if you just factor T1 out of this guy over here, sometimes it's written as this: Sn equals T1 R to the N minus 1. And guys, I think this is the way it's on your formula sheet. So all we did here is we factored out a T1 here and here. So the T1 comes out in front, R to the N is here, and then if I factor T1 under this term, it's just minus 1 over R minus 1 like this. So I think this is the version that you guys see on your formula sheet for this one over here. All right, so our formula is Sn equals T1 R to the N minus 1 over R minus 1. Okay, so in this case, we want to figure out S10. So looking at this one over here, hopefully you guys can see that T1 equals 40. If I go 10 divided by negative 20, my common ratio is negative 1/2. And I could have gotten that by dividing any two consecutive terms like this. And really, guys, this is all we need for this formula now. S10 equals 40 negative 1/2 to the 10 minus 1 over negative 1/2 minus 1. I'm going to show you how to do this on your calculator here, guys. Bear with me for 1 sec. Sorry, guys, 1 sec here. All right, so on your calculator, we're going to go for guys, I think it's easier if you go and use the math and go down to math number numerator divided by denominator here, so we can actually input a fraction, and we want to put in our T1 is 40 bracket. I'm going to put another bracket here, so I want to put a negative 1/2 like this, exponent 10 minus 1, close the bracket, divided by negative 1/2 minus 1, like this, and gives me this answer over here, which is 1705 over 64. Okay, next one. Same idea over here. We're going to look at our 270 is our T1, our common ratio. If I just go 90 divided by 270, guys, this simplifies to 1/3. Okay, and we know that n equals 8. Okay, so that equals T1, which is 270, Our R is 1/3, so I'm going to put this in brackets to the 8th minus 1 over 1/3 minus 1. Bear with me for 1 second here, guys. I just need to write this down on a piece of paper before I go to my calculator screen because I won't be able to remember it all. So we have, let's make a fraction, and you want to go 270, open your bracket, 1/3 exponent 8 minus 1, close the bracket here, and then we want 1/3 minus 1 in the denominator. It gives us 32,801. Sorry, 32,800 over 81, and that is going to be the answer for this sum over here. All right, similar idea for this question over here. A bit more work. What's going to be our common ratio here? So our ratio is, if I divide this by this, 1/10 divided by 1/4 is 1/10 times 4 over 1, which is 4 over 10, which is 2/5. This is our common ratio, okay? We know that T1 equals 1/4, and we want, so we know that N equals 7 because we're looking for S7 here. So that means Sn equals T1 R to the N minus 1 over R minus 1. T1 is 1/4, 2/5 to the 7th minus 1 over 2/5 minus 1. So let's fire this guy into your calculator, and we're going to get 1/4 bracket bracket 2/5 to the 7th minus 1, close your bracket there, over 2/5 minus 1. Okay, so guys, this one was not giving me, this guy was not going to actually give me a decent number for a fraction over here. It's not converting for it. So we'll just take this one and let's round to, let's say, 2 decimal places here, guys. We're at 0.42. And that's going to be our answer for this guy over here. All right, so example 25, what is the value of the first term of the geometric series described? We know R equals 4, S6 equals 685. So that means S6 equals this. That means N equals 6. That means R equals 4. We're looking for T1. Oops, T1 is question mark. So Sn equals T1, R to the N minus 1 over R minus 1. So let's plug in these values. We get 6,825 equals T1. That's what we're looking for. 4 to the 6th minus 1 over 4 minus 1. Now, 4 to the 6th minus 1 is 4,095 over 3. So I'm just going to multiply both sides times 3. Divide both sides by 4,095. Plug that in your calculator, guys, and we get 5 equals T1. So it's 3 times 6,825 divided by 4,095. And this answer is T1 equals 5. All right, similar idea over here, guys. Just numbers are a little bit more complicated. So we have S9. We know that N equals 9. We know that R equals 1/2. We're looking for T1. Don't know it. It's 12/7. There we go. So we got 12775 over 16 equals T1 1/2 to the 9th minus 1 over 1/2 minus 1. Okay, I'm just going to do this in a few extra steps here, guys. I'm just going to multiply both sides times negative 1/2. Okay, and this gives us negative 12775 over 32 equals T1 times negative 511 or 512. Because what I'm going to multiply times, I'm going to go times 512 over 511. Okay, and that means these guys are going to cancel out here and here. I'm going to multiply times 512 over 511. Okay, so those guys cancel out here. And we get this answer gives us T1 equals 400, and that's how this question works out over here. All right. Example 26. A basketball dropped from a height of 10 meters bounces to 40% of its original height on each bounce. The total vertical distance traveled is made up by the upward bounces and downward drops. So the idea is over here, if here's your ball, it's going to drop down 10 meters. And then if it's to go 10 times 0.4, I get 4. That means it bounces up 4, and it's going to go down 4. And then 4 times 0.4 is 1.6. So that means it goes up 1.6 and then down 1.6. And if I go 1.6 times 0.4, you get 0.64. That means it goes up 0.64, down 0.64. So here's what our sum is. If I count all the down arrows, sound good? And then if I get all the up arrows, it's going to be 4. So it's not going up 10, remember, it's only going down because it's dropped from a height of 10. Okay, what's the total vertical distance the ball has traveled when it hits the floor for the 6th time? Okay, so what I'm going to do, because hopefully what we see is like this is the same thing as this part. So we're going to figure out this part over here, multiply it times 2, and then add this 10 over here. Okay, so I'm adding for the 6th time would be S6, and we know that Sn equals T1 r to the n minus 1 over r minus 1. So S6, T1 is 4. Our value of r is 0.4 to the 6th minus 1, or 0.4 minus 1. Guys, I'm just going to fire this in my calculator here. they want the nearest tenth of a meter. So guys, I'm just going to go like 6.63. I'll round in my last step. Okay, so we have 6.63936. We're going to multiply that times 2 because it happened here and here. And then we're going to add 10 for this guy right over here. Times 2 plus 10. Equals 56.6 meters. This is going to be a total answer for this guy over here. All right, guys. Hope that one made sense. All right, guys. So that's our topic of geometric series. We have one more topic in this chapter here, guys, called infinite geometric series, and I'll let you know about that one in the next video.